find the problem where patient not able or willing to take medication. Yeah, this is a drug-related problem that should be considered when the pharmacists do the clinical pharmacy activity, pharmaceutical care. And yeah, there are several factors that can influence the medicine response. First is, of course, the right diagnosis. If the patient the right diagnosis, they can get the right drug with the right dosage regimen. Yeah, if the patient get the right diagnosis and dose regimen, and then they comply, and also we can manage the interaction within with the concomitant drugs, so patient will respond well. But there is still one factors that may influence the patient response to drug, namely a genetic difference among patients. So even though they have a right diagnosis, right dose regimen, they comply to the medication, and also the interaction with concomitant drugs can be managed, but there is still other factor that can influence the medicine response, namely the genetic difference among patients. So based on this genetic difference, we know the term precision medicine. So the precision medicine is maybe before you already heard about the personalized medicine. Yeah, the personalized medicine is old term. Yeah, but now the term, the most used term is precision medicine, which is the definition is the use of genetic, environmental, lifestyle, and other unique patient or disease characteristic to guide drug selection and dosage, and the more focus on the genetic profile. Yeah, it can be illustrated here. This is a patient group with the same diagnosis and same prescription, but then they can respond differently to the medication. There are at least 4 groups that can be occur. Yeah, the first group. This is maybe the most lucky one. Yeah, the luckiest group, because the drug not toxic and beneficial for the patient. But excuse me, please mute all the. Yeah. Okay. Thank you. And the second group is maybe the unluckiest one, because the drug toxic and not beneficial. And the third category is the people that the response of drug toxic but still beneficial. And the fourth group, the drug may be not toxic and not beneficial. So there are 4 kind of groups according to the response to the medication. This is based on the genetic profile. This is can be influenced by genetic profile of the patient. So we know the study about pharmacogenomics. Pharmacogenomics is a study how genes affect a person's response to drug. This is a relatively new field, combines pharmacology and genomic. So the pharmacogenomics. Genomic itself is the study of gene and their function. So the pharmacogenomic is a study to develop the effective, safe medication and doses that will be tailored to a person genetic makeup. So based on the genetic profile of the person, then the clinician can decide the certain medication. And in the foundation of pharmacogenomic, we have to know about the difference between the mutation and polymorphism. There is 2 terms that often used in the term of genomic or genetic study. The first is mutation. Mutation is a difference in DNA code that occurs in less than 1% of population. It is often associated with rare disease like cystic fibrosis, sickle cell anemia, Huntington disease, etc. While for a polymorphism is difference in the DNA code that occurs in more than 1%. So this is the difference. This is a less than 1%, and in polymorphism can be more than 1% of the population. Actually, a single polymorphism is less likely to be the main cause of the disease, but the polymorphism often have no visible clinical impact, but may cause inter-individual variability in drug response. So depend on the kind of polymorphism, they can be no meaning at all, or they have impact on the drug response. Polymorphism itself occurs in can be occur in transporter, enzyme, receptor, and also other therapeutic target. There is a term, namely single nucleotide polymorphism, or SNP. Yeah, we usually pronounce it SNP. It is a type of polymorphism for which variation occurs only in a single nucleotide base. Yeah. So in the pharmacogenomic study, we often found the term polymorphism. Polymorphism have a consequence like it may result in different amino acid or stop codon. It may result in a change in the protein function or quantity. It may alter stability of mRNA, or maybe no consequence at all. Just depend on the type of the polymorphism or the SNP. Yeah. So as I previously mentioned, that pharmacogenomic can occur on several targets. So it can be on the drug target like receptor, enzyme, and also in drug transporter that transport the drug from the one compartment to other compartment, and also in drug metabolizing enzyme. So in the term of pharmacology, we know the pharmacodynamics and pharmacokinetics. So the pharmacogenomic can influence the pharmacodynamic aspect and also pharmacokinetic aspect. And all can contribute to the variability in efficacy and toxicity of the drug. Okay, yeah? And yeah, we know start with the pharmacogenomic in drug metabolizing enzyme. Yeah, this is the most common SNP or polymorphism happen, yeah, for the effect of the drug. We know that in the metabolism, there is a CYP450, yeah. CYP450 is an enzyme that is most dominant to metabolize many drugs, yeah, that used by human, and it's still divided into, or it consists of several types or subtypes like CYP2D6 to CYP2 3A4, CYP1A2, and etc. The most dominant is CYP3A4, followed by CYP2D6, and other dominant is CYP2C8 or 9. Yeah, and many drugs is metabolized by certain subtype of CYP, P450. And from the some CYPs, the CYP2D6, 2C9, and 2C19 are the three largest isoforms undergoing genetic polymorphism. So the enzyme, this is the enzyme, the gene of that support this synthesis of this enzyme can do polymorphism, and it contributes to the various phenotypes. Yeah, this is the polymorphism in the CYP gene. So the polymorphism of CYP gene can produce enzyme product with abolish or reduce or alter or increase enzyme activity. So the phenotype of the SIP when it undergo the polymorphism, that can be four major phenotype. The first is a poor metabolizer. The people usually lacking of functional enzyme. The poor metabolizer like this. So if the metabolism is less because it poor metabolizer, the active drug become high, or the bioavailability of the drug become higher. Yeah. So if the drug have a narrow therapeutic index, it can pass the toxic dose, yeah, or toxic effect. They can show toxic effect. The optimal or the normal is, still normal is intermediate metabolizer and efficient metabolizer. The wild type is the efficient metabolizer. And the last phenotype is the ultra rapid metabolizer. So when the SIP gene is undergo the polymorphism, that can result in a phenotype like ultra rapid metabolizer, where the people that have enzyme that ultra rapid metabolizer, so the metabolism of drug is very fast, yeah, very rapid. So the active drug becoming very low, or because they rapidly inactivated or metabolized by P450 enzyme. Yeah, this is the implication or the effect of polymorphism in the SIP genes. Yeah, I did an experiment or a research in Indonesian Bugis population and studied the polymorphism of SIP to C19 and to C9 and to C19, and we found that there is no slow metabolizer, but on 16% of the female of our subject saw the fast metabolizer. Yeah, because they have a polymorphism, star 7, star 1, and star 17 like this. Yeah, yeah. This is our study in 2014, and this is our study in 2019. We did in other population, Indonesian population, for SIP to D6. In the SIP to D6, we found also some polymorphism, yeah, especially in the star 10. Yeah, the SIP to D6 is enzyme responsible for opioid or opioid compound metabolism. Yeah. It is our interest to study the prevalence in drug-addicted population. Yeah. In this research, I did in the drug-addicted population and also in the normal population, and we compare this. Allele star 10 and star 17 are related to reduced function of enzyme, meaning that it become a slow metabolizer. However, we didn't find any significant correlation, but in fact, we have data that some of us have a polymorphism in SIP to D6, yeah, for metabolism. Yeah, this is compare with other population in East Asia. It is actually common to have polymorphism in star 10, star 10. This is in our population in Indonesia. I did in 2019. And if we compare with other populations, so the East Asian, like Indonesia, as actually are reported to be high in the polymorphism of 2D6 gene. Yeah, okay. In developed country, it is already available the first pharmacogenetic test, AmpliChip SIP CYP450. Yeah, this is to measure SIP to D6 and to C19 gene polymorphism. It is very helpful because by using these tools, we can determine the profile of our genetic. especially in the CYP2D6 and to CYP19, because it can be used for personalize our medicine. Yeah, this is the microarray based test to determine the genetic variation. And in the developed country like in US, and where the genetic test is mostly done, there are several requirements for the drugs. Like there are several drugs, especially in cancer therapy and also in other therapy like warfarin, clopidogrel, that is recommended to use a genetic profile when determine the dosage of the therapy. Yeah, here I show you some example for the irinotecan, warfarin, and clopidogrel, where it is recommended to have a genetic test before prescribe the drug. Yeah, to make it more specific and more precise about the dosage. Yeah, irinotecan. Irinotecan is one of the anti-cancer therapy. It's a prodrug. It is a active metabolite of SN30, and it acts as inhibitor of topoisomerase 1. In turn, it can inhibit cancer cell proliferation. Metabolism and excretion of the SN31 is catalyzed by UGT1A, uridine diphosphoglucuronyl transferase enzyme, via glucuronidation. Some people might have genetic variation of this enzyme, genetic variation of the gene that encode the enzyme. So it can cause variation in enzymatic activity. In turn, it can result in variation in adverse effect and toxicity. Yeah, this is irinotecan, is a prodrug, and then after they enter the liver, yeah, then it can be metabolized, yeah, to be a SN31. This is the active form. And then it can be followed by metabolism by UGT1A to be the inactive form. So this is very important because many toxicity are reported when this there is a variation or there is less activity of this enzyme. Yeah, because the active form is too high, then it can cause the toxicity of the irinotecan. Yeah, this is the example why we need to test the genetic variation before prescribing the medication, usually for the specific medication. Yeah, this is the irinotecan and toxicity. Yeah, if the SN38 form is too high because it is less active, so then the metabolite is inhibited, metabolism is inhibited, it is accumulated too high, it can affect on bone marrow, and it can cause the toxicity like leukopenia, thrombocytopenia, also anemia. And yeah, this also can increase the toxicity and in intestine like diarrhea. Yeah, this is the example when there is a variation of the genetic or there is a polymorphism in the gene that encode this enzyme. Yeah, this is the one example. So the increase of the availability of SN38 will increase the risk of toxicity. That's why in the certain patient that have polymorphism, the drug dosage should be considered to be lower. Yeah, so it should be adjusted to the condition of the polymorphism. Yeah, So there is sufficient data to recommend that patient with genetic profile of homozygous for 1322 should not receive irinotecan therapy with standard dose, yeah, due to high risk of toxicity. It means that the one that have genetic profile like this, and it means that the enzyme activity is less, so the standard dose should be lower, yeah, or they should not receive irinotecan therapy with the standard dose. So the option is to reduce the dose or use another drug regimen, yeah, instead of the irinotecan. So this is the first option. And other example is a pharmacogenomic in clopidogrel. Clopidogrel is very commonly used for example like stroke. Yeah. Clopidogrel also is prodrug. Yeah, clopidogrel when it enter the liver, then they will be metabolized. It will be metabolized by several CYP like CYP2C19, etc. But it undergo twice, two times metabolism, which is mostly or dominated by CYP2C19. So after the metabolism of the prodrug, it can result in active metabolite. The active metabolite will act on the receptor, yeah, to have the activity. So if there is a polymorphism happen in the gene and code this CYP2C19 becoming lower activity, so the active metabolite will be less, yeah, than expected, yeah. So if there is a low metabolizer, a slow metabolizer here because the less activity, the activity of the clopidogrel becoming less and the effect also becoming less than expected. So in the clopidogrel, there is information in this in the package insert mention that Plavix at recommended dose form less of that metabolite and has a smaller effect on platelet function in patients who are poor metabolizer. Poor metabolizer with acute coronary syndrome or undergoing percutaneous coronary intervention treated with Plavix at recommended dose exhibit higher cardiovascular event rates than do patient with normal CYP2C19 function, meaning that the test should be done for the patient to identify whether is it a poor metabolizer or not. If so, we can have other recommendation. Yeah. So in the USA, for example, on the developed country, tests are available to identify the patient's CYP2C19 genotype, like this I previously mentioned. This test can be used as an aid in determining therapeutic strategy. And if the patient is identified as CYP2C19 poor metabolizer, so then we can recommend the patient to, for example, to change the other, not clopidogrel, but for example, prasugrel, or maybe we can increase the dose, for example. Yeah, because clopidogrel, as I mentioned before, it is metabolized by 2C9 twice, yeah, while prasugrel only once, so it is not highly effective, affected by the polymorphism. So it can be a choice instead of clopidogrel when the patient have or identified as a slow metabolizer due to polymorphism in 2C19 gene. Yeah. Okay, this is the example. And the last example is warfarin. You know that warfarin is very common also to use in as anticoagulant, yeah, anticoagulant therapy. Warfarin works in by inhibiting vitamin K epoxide reductase or VCOR. Yeah, VCOR helps recycle vitamin K, which is important in proper functioning of clotting factor. By inhibiting VCOR, warfarin alters the vitamin K cycle and result in the production of inactive clotting factor. So it can inhibit the coagulation. But the polymorphism exists in the gene for VCOR, or the name of the gene is VCOR C1. Yeah, so if the VCOR C1 is undergo the polymorphism, they will have the different response. So I can show you here that there are two kind of polymorphism happen or should be considered in warfarin therapy. First is in metabolism with 2C9 and VCOR C1. Yeah, if there is combination between CYP2C19 and VCOR C1, and both of them are polymorphic, so it can very important when very influenced with the concentration or the dose need for warfarin. Yeah, so maybe we can see the table. This is the dosing recommendation with consideration of genotype. Yeah, there is in the aspect of pharmacodynamic, VCOR C1 itself is the target of the warfarin. It can be polymorphic also, and when the polymorphic happen, like becoming AA, yeah, this is the resistant to medication, and AG, this is a wild type, and GG is mildly resistant. And this is the CYP2C9. This is the CYP that metabolize the warfarin, and it is also can be polymorphic and can show the decrease of enzymatic activity. So you can see here, if the person or the patient have wild type, so normal, yeah, for the VCOR C1 normal, yeah, here, and the CYP2C9 normal, so they need the dose of 5 to 7 milligram. But when it undergo the polymorphism, for example, STAR3, this is slow metabolizer, and AA mean sensitive, so they only need 0.5 to 2 milligrams. So you see the different, very different concentration need when the patient have certain genotype profile. Yeah, this is the why we should consider the genotype profile when prescribe certain medication, when it's already known about the genetic profile. Yeah, yeah. How about the challenge for clinical pharmacists? Yeah, actually we know that pharmacogenomic testing is believed to be able to improve medication-related outcome. It can reduce suboptimal clinical outcome. It can decrease cost of treatment. It can give the better medication adherence and more appropriate selection of therapeutic agent, decrease length of treatment, and enhance patient safety. So I recommend that clinical pharmacists should possess a basic and functional knowledge of pharmacogenomic to adequately support application at their practice site. Clinical pharmacists should consider genetic factor when evaluating the drug therapy problem and take appropriate action. Yeah, but unfortunately in our country, maybe the genetic tests, some like I previously show you, maybe still very limited. Yeah, so only in the maybe only in experimental environment, yeah, but not in the daily services. Yeah, but actually, I believe that there is still opportunity, yeah, for us, because in the certain specific disease like cardiovascular disease and cancer, which is very crucial and very critical, and the drug is also expensive. The implementation of pharmacogenomic has been very useful, yeah. And in this field, pharmacogenetic testing is already applied for selecting and or dosing a specific medication. And just now, several pharmacogenetic tests have been developed, and there is a high expectation of the patient to have more cost-effective medicine with less adverse effects, especially for expensive medication. So you know that most of biological agent for cancer therapy is very expensive. If we can give the appropriate medicine, appropriate choice, and appropriate dose, I think it is very helpful for the patient, yeah, to get the cost-effective medication and also safer medication for the patient. And pharmacists can contribute more to ensure the effectiveness and safety of the medication therapy by promoting the optimal use and timing of pharmacogenomic tests and interpreting clinical pharmacogenomic test results and educating other pharmacists or fellow healthcare professional, patient, and the public about the field of pharmacogenomics. I think this field is getting more interest, yeah, more interesting today to know about the genetic factor that influence the response of the patient to the drug. Okay. I come to the conclusion that the implementation of pharmacogenomic testing for the design of personalized prescription still face a number of barriers, yeah, to be integrated into clinical practice. However, the increasing knowledge on the molecular basis of response to medication, EDRs, and disease susceptibility, and the growing attention of pharmaceutical industry and national healthcare policymaker will accelerate the pace toward the achievement of precision medicine, hopefully. Yeah. Okay. I think that I can share today. I hope you can get some insight from my presentation, and we can discuss later in the Q&A session. Okay. Back the time to Mbak Maya as moderator. Thank you very much for attention. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Prof, for giving us the informative and interesting presentation. Very new knowledge for us. And ladies and gentlemen, now we come to question and answer session. You can write down your name and your question at chat column. Maybe we can discuss in Indonesian, yeah. And Prof, to make it as easier to understand, maybe you can answer it in Indonesian too.
Yeah.
The first question, pertanyaan pertama dari Pak Reza, Prof.
Yeah.
Izin bertanya, pertanyaan tersebut pengobatan polimorfisme termasuk terapi genetik, tetapi bagaimana jika tingkat keberhasilan di Indonesia karena dari yang dipelajari seseorang dengan kelainan genetis ternyata sangat susah disembuhkan, Prof. Silakan.
Baik, ya. Oke, terima kasih atas pertanyaannya. Maaf saya menggunakan bahasa Inggris tadi karena moderatornya udah pakai bahasa Inggris, jadi saya melanjutkan aja. Tapi begini ya, saya akan menjelaskan secara singkat bahwa ini sebetulnya bukan lagi ngomong tentang penyakit genetik, ya, bukan tentang penyakit genetik, tetapi bahwa faktor genetik itu bisa mempengaruhi respon seseorang terhadap obat. Ketika seseorang nih tadi saya sampaikan ada satu kelompok orang yang dia penyakitnya sama, ya, kemudian mendapatkan resep yang sama, tapi ada yang saya kok sembuh ya pakai ini, tapi kok dia pakai obat yang sama nggak sembuh, kan gitu, sebetulnya lebih ke situ, ya. Kemudian mungkin ada orang yang menggunakan obat yang sama, dia mendapatkan efek samping, kok saya enggak ya gitu. Jadi bahwa ternyata respon seseorang terhadap obat itu bisa dipengaruhi oleh faktor genetik. Nah, faktor genetik itu, jadi kita lagi nggak ngomong tentang penyakit genetik, bukan. Tapi bahwa ada faktor genetik yang bisa mempengaruhi bagaimana kita merespon terhadap adanya obat. Dan faktor genetik itu ada istilahnya adalah polimorfisme. Ya. Polimorfisme itu adalah perubahan pada single DNA gitu ya, atau satu yang itu bisa terjadi pada lebih dari 1% populasi. Jadi kalau yang namanya mutasi itu yang paling, yang itu tadi yang Bapak bilang, Bapak atau Ibu sini Mbak. Jadi yang tadi disebutkan ada penyakit apa ya, misalnya cystic fibrosis atau penyakit genetik, itu memang susah. Kalau itu memang susah ya, itu namanya mutasi ya, ada mutasi. Secara umum istilahnya adalah mutasi. Itu adalah biasanya pada penyakit-penyakit yang jarang begitu. Tapi pada polimorfisme ini kejadiannya lebih banyak sebetulnya, dan itu commonly kita terjadi gitu ya. Yang tadi menyebabkan respon itu berbeda. Nah, sehingga sebetulnya tadi polimorfisme itu bisa mempengaruhi di aspek farmakokinetik dan farmakodinamik. Kalau farmakodinamik itu berarti pada reseptornya. Saya contohkan tadi dengan warfarin atau mungkin ya warfarin misalnya. Warfarin itu kerjanya di fikorsi ya. Jadi ada enzim namanya fikorsi tadi ya. Yang itu nanti dipengaruhi oleh warfarin. Tapi ternyata enzim itu sendiri juga bisa beda-beda tadi. Ada yang sensitif, ada yang resisten gitu loh. Karena adanya perubahan genetik itu tadi. Nah, sehingga ketika ada warfarin, maka responnya bisa beda-beda. Apalagi jika dia dikombinasi dengan metabolisme yang berubah juga. Jadi, tadi aspek farmakodinamik. Nah, aspek farmakokinetik itu banyak dijumpai pada enzim pemetabolisme. Jadi kita tahu ya, obat itu kan di metabolisme nih. Secara umum ya, obat itu di metabolisme menjadi bentuk yang tidak aktif, ya, menjadi inaktif untuk kemudian dikeluarkan. Namun memang pada kondisi tertentu, misalnya certain drug, misalnya prodrug tadi ya, contohnya clopidogrel itu adalah prodrug. Kalau prodrug itu berarti dia dari tidak aktif menjadi aktif begitu. Nah, kebetulan contoh yang prodrug tadi clopidogrel misalnya, dia dimetabolisir oleh CYP2C19 ya, 2C19. Nah, kalau terjadi polimorfisme pada si gen yang menyandi pembentukan si enzim C19 tadi, maka nanti bisa menyebabkan si tadi menghasilkan enzim yang apa namanya, functionnya berkurang, jadi menjadi slow gitu ya, menjadi slower metabolizer atau poor metabolizer. Maka kalau misalnya dia poor, maka pembentukan dia dari prodrug menjadi drug kan menjadi berkurang. Makanya orang-orang yang mengalami mengalami polimorfisme di CYP2C19, dia kalau pakai clopidogrel, dia tidak seefektif kalau orang normal gitu. Karena obat aktifnya menjadi lebih sedikit dibandingkan dengan orang normal. Sebetulnya seperti itu ya, teman-teman ya. Jadi dan itu di negara-negara maju itu sudah ada tesnya. Jadi tapi yang SIP ini, terutama yang SIP ini karena yang paling sering dijumpai ya. Jadi CYP2C19 itu udah ada kitnya yang itu tadi. Jadi di luar negeri itu yang mungkin di negara maju di Amerika, mereka label obat itu sudah harus menyertakan pharmacogenomic labeling. Jadi misalnya nanti tadi kayak yang di Plavix itu ya, itu udah ada orang-orang dengan slow metabolizer, nanti berarti dia harus begini misalnya gitu. Misalnya harus diperhatikan, harus ditingkatkan dosisnya atau yang lain lah begitu. Jadi seperti itu yang dimaksudkan ya. Jadi di sini bukan menterapi suatu penyakit genetik, bukan ya. Dalam hal ini adalah bukan terapi genetik juga. Jadi bahwa faktor genetik bisa mempengaruhi respon seseorang terhadap obat, sehingga obat itu perlu di personalize jadi digunakan sangat individual. Si A ini mungkin butuhnya sekian dosisnya, si B ini dengan genetik profil seperti ini mungkin obat yang sama butuhnya lebih tinggi atau lebih kurang begitu. Itu lebih utamanya di situ untuk personalized medicine atau precision medicine. Begitu. Apakah sudah cukup menjawab?
Baik, terima kasih untuk jawabannya, Prof. Sudah sangat jelas. Mungkin kita beralih ke pertanyaan selanjutnya. Di sini dari Cucu ingin bertanya, bagaimana penggunaan farmakogenomik ini dalam praktis? Ya, kemudian bagaimana langkah-langkahnya ketika diaplikasikan ke pasien, Prof? Terima kasih.
Ya, itu tadi memang kita bariernya atau tantangannya kita belum terlalu biasa menggunakan tes genetik. Tapi kalau jadi biasanya mungkin harus prioritas ya, harus pilih-pilih. Yang udah mulai diutamakan itu atau yang udah mulai dilakukan, diprioritaskan adalah pada pasien kanker, terutama yang menggunakan obat-obat agen biologis yang mahal-mahal itu ya, yang pakai map-map gitu ya, yang targeted terapi. Itu tuh gini, karena kalau misalnya udah mahal, tapi ternyata sebetulnya targetnya itu tidak respon ya, artinya tidak cocok, kan sayang. Nah, makanya untuk mereka yang obatnya mahal-mahal itu, biasanya direkomendasikan untuk dites dulu. Katakanlah misalnya HER2 ya misalnya ya, atau ada nggak sih sebetulnya ekspresi dari protein tertentu pada si pasien itu, sehingga obat ini cocok nggak gitu, karena obatnya mahal. Tapi kalau cuma paracetamol mah nggak usah gitu ya, nggak perlu ada genetik test untuk paracetamol. Tapi yang murah-murah tuh mungkin nggak terlalu. Jadi terus tadi misalnya indeks terapi sempit kayak warfarin ya, warfarin itu kalau di luar itu disarankan, jadi memang aplikasinya harus dites dulu gitu loh. Dan itu jadi kalau misalnya tadi saya sampaikan, saya memang pernah beberapa kali ya melakukan penelitian untuk farmakogenomik. Kita melihatnya lebih kepada database dulu aja, persentase. Oh ternyata banyak ya di Indonesia. Oh dibandingkan dengan Kaukasian misalnya, dengan etnis yang lain ya, dengan ras lain, kira-kira kejadiannya seperti apa gitu. Nah, tapi itu saja tidak bisa menjadi, belum berbunyi apa-apa. Tapi nanti aplikasi dari farmakogenomik adalah ya ketika udah dites pada masing-masing orang begitu. Jadi memang idealnya nanti akan ada gitu ya, genetic testing yang mendahului atau sebelum satu prescription gitu. Jadi yang udah berjalan mungkin kalau yang tadi yang setahu saya mungkin ya memang tidak terlalu banyak juga karena mungkin juga harganya juga ya. Itu untuk kanker terapi ya, terapi kanker terutama yang menggunakan obat-obat yang mahal itu disarankan untuk melakukan genetic testing dulu. Dan itu available ya. Sebetulnya genetic testingnya nggak sulit. Artinya di Indonesia itu bisa gitu ya. Juga masalahnya kan ini kan belum masuk dalam BPJS. Siapa yang membayarin? Apalagi kalau pasien BPJS ya. Jadi biasanya lebih kepada kalau memang pasiennya bisa gitu ya nggak apa-apa. Biasanya ada genetic testing tertentu ya yang itu bisa dilakukan. Seperti itu. Kalau mungkin di rumah sakit besar yang berafiliasi atau mungkin ya bekerja sama dengan, yang saya tahu saya yang lebih utama di kanker ya, kanker terapi yang menggunakan obat-obat yang mahal itu memang disarankan begitu untuk genetic testing. Begitu Mbak Cucu.
Baik, Prof. Terima kasih untuk penjelasannya. Baik, kemudian ada pertanyaan lagi, Prof.
Ya.
Dari Febriana
Ya.
Lulu. Mohon izin bertanya. Pertanyaannya, penyebab polimorfisme dari gen tersebut. Bagaimana, Prof? Terima
Itu
kasih.
penyebabnya takdir ya. Jadi kita nggak ngerti. Jadi terus terang kalau saya juga, jadi gini, memang beberapa kayak gen itu bisa inherited ya. Jadi kan bisa juga diturunkan dari orang tua. Jadi genetik itu ya tadi kadang-kadang bisa diturunkan, dan jadi terus terang saya pribadi nggak tahu. Memang ada beberapa, mungkin ada faktor environment gitu ya, bisa menyebabkan, katakanlah misalnya kanker ya. Kanker itu kan sebenarnya kan masalah genetik juga, kan ada mutasi yang kemudian menyebabkan dia proliferasi, dan itu bisa disebabkan karena adanya suatu karsinogenik atau apa gitu. Tapi itu mutasi dalam hal itu contohnya kanker ya. Tapi kalau yang polimorfisme yang tadi itu, yang kayak terjadi polimorfisme pada enzim tertentu ya di sitokrom P450, itu nggak bisa dikatakan penyebabnya ya. Jadi kita bahkan penyakit atau nggak dipengaruhi oleh itu. Jadi kalau kami kemarin mencari subjek untuk studi ini ya, uji polimorfisme itu ya, kita bisa ambil anyone, bahkan orang sakit pun nggak apa-apa karena dia tidak akan terpengaruh oleh penyakit gitu loh. Jadi gen itu ya udah ada dalam tubuh gitu loh sejak dia lahir gitu. Jadi saya kira nggak ada penyebab khusus ya terjadinya polimorfisme gen itu.
Baik.
Dan itu mungkin seumur hidup akan sama terus gitu. Jadi kayak udah jadi profilnya orang itu gitu. Makanya saya membayangkan kan sekarang ini kan kita sering ya, zaman dulu nggak kebayang tuh ada kita membayar pakai kartu aja langsung ditempelkan bisa gitu ya. Zaman dulu saya masih terheran-heran kok bisa ketika pas keluar negeri gitu. Nah sekarang mungkin tadi ya KTP kan juga bisa ada e-KTP ya. Nah mungkin nanti data-data genetik bisa diinsertkan. Nah itu akan lebih bagus lagi kalau kelak gitu ya. Mungkin data-data kita bisa tambahkan data genetik sehingga ketika kita periksa ke dokter langsung lihat oh ini anunya slow metabolizer nih, oh ini fast metabolizer nih. Nah ini berarti nanti kira-kira obatnya dosisnya seberapa atau pilihannya apa itu bisa. Itu mimpinya ya ke depan seperti itu. Demikian Mbak Maya.
Baik, terima kasih Prof. Mungkin ada lagi pertanyaan dari Ibu Melania. Apakah maaf Prof, ada dari Pak Reza, izin bertanya kembali Prof, terkait dengan farmakogenomik yang biasa dikembangkan untuk kanker, apakah sudah dikembangkan obat farmakogenomik ini untuk masalah fertilitas, misalnya orang kesulitan hamil, karena kadang ada beberapa obat hormon yang berefek pada satu orang tetapi tidak dengan orang lain. Terima kasih, Prof.
Ya, terima kasih pertanyaannya. Jadi istilahnya bukan obat farmakogenomik ya, karena farmakogenomik itu sendiri bukan suatu obat ya. Jadi tesnya mungkin ya, tes farmakogenomik. Saya kurang tahu kalau yang ini mungkin ada ya. Jadi saya kebetulan belum membaca terkait sama khususnya untuk yang fertilitas ya. Tapi ini sebetulnya adalah common hal yang umum ya, artinya bahwa ketika ada satu obat atau hormon yang tidak berefek pada satu orang tapi berefek pada yang lain, mungkin ada faktor genetik. Cuman genetiknya apa itu kita harus mempelajari dulu gitu. Termasuk langsung pertanyaan Mbak Melania nih ya. Jadi apa saja polimorfisme itu nggak bisa gitu Mbak, belum bisa kita sampaikan bahwa yang paling banyak itu apa, karena gen itu banyak sekali gitu ya. Jadi tapi secara umum tadi terkait dengan metabolisme aja dulu ya. Di metabolisme itu SIP yang paling banyak mengalami gen yang paling banyak polimorfisme di bidang metabolisme itu adalah 3 macam tadi, SIP 2D6, 2C9, 2C19. Tapi tidak menutup kemungkinan mungkin ada orang lain juga yang mengalami polimorfisme pada SIP yang lain begitu. Jadi kita dari angka-angka itu tadi ya, kemudian itu baru di metabolisme, belum nanti di target ya. Saya pernah juga membimbing satu penelitian, targetnya adalah OPMR1. OPMR1 itu gen untuk opiat reseptor misalnya. Nah, ternyata juga ada di opiat reseptor sendiri ada berapa persen populasi Indonesia yang mengalami polimorfisme juga di situ. Ada lagi di dopamin reseptor. Nah, itu kan banyak sekali. Jadi kita nggak bisa menyebutkan bahwa jenis apa itu nggak bisa. Ya. Jadi itu spesifik pada gen tertentu, nanti kira-kira prevalensinya berapa yang ada itu mungkin ada. Itu pun kalau di Indonesia belum banyak kajiannya. Gitu.
Baik, Prof. Terima kasih untuk penjelasannya. Mungkin satu pertanyaan penutup, Prof, dari saya. Mungkin Prof, kalau di luar negeri sendiri, apakah sudah berkembang untuk penyakit selain kanker ya, Prof? Misalnya sudah, apa saja, Prof, yang sudah ada di luar negeri tersebut? Terima kasih.
Iya, terima kasih Mbak Maya. Tadi saya sampaikan ya, contohnya warfarin aja. Itu di sana udah ada tadi, bahkan labelnya udah seperti itu. Dan itu tesnya cuma Vicorsi sama SIP2C9. Itu mereka udah recommended ya dipakai. Jadi kalau di kita kan warfarin pakai aja gitu ya, nggak kepikir ya. Tapi sebetulnya di dalam label dari obat itu tadi, karena ternyata Vicorsi itu bisa mengalami polimorfisme juga gennya. Sehingga tadi ternyata ada orang-orang yang Vicorsinya, enzimnya itu ada yang sensitif, ada yang resisten gitu, ada yang biasa aja gitu. Nah, itu aja sudah bisa mempengaruhi dosis obat yang dibutuhkan. Kenapa warfarin penting? Karena dia indeks terapinya sempit, ya terjadi perdarahan kan bahaya ya. Apalagi kan dipakai agak lama juga. Jadi makanya orang memberikan perhatian, atau para ahli ini memberikan perhatian pada itu. Dan belum lagi dikombinasi sama aspek metabolismenya. Jadi udah ininya sensitif, kemudian dia slow metabolizer, berarti apa? Dia tidak mudah berubah. Jadi zat aktifnya tinggi, jadi bahan obat aktifnya tinggi, maka akan menjadi ketika digunakan pada dosis yang sama aja seperti tadi ya, yang dosis normal, dia akan menjadi toksik begitu, menjadi efek perdarahannya menjadi besar. Makanya untuk yang seperti itu dosisnya bahkan hanya 1/10 tadi Anda lihat, 3-5 misalnya itu bawahnya 0,5 ya. Artinya apa? Itu udah 1/10 kali yang direkomendasikan. Kalau nggak seperti itu tadi resikonya perdarahan. Nah, kalau di Indonesia orang ketemu resiko dulu baru dipikir gitu ya. Oh, mungkin udah terjadi nih resiko, tapi kan karena nggak ada prediksi, maka udah kejadian dulu. Bahkan siapa tahu mungkin ada yang fatal juga begitu ya. Tapi ini memang tujuannya adalah prediksi ya teman-teman. Jadi precision medicine itu sifatnya adalah sebagai prediktor. Apakah dia bakal efektif atau enggak, ataukah bakal aman atau enggak begitu. Dengan mengetahui itu, kita nanti akan memilihkan tadi obat yang dengan dosis yang tepat, kemudian dengan mungkin pilihan yang lain. Kalau ternyata nggak bagus ya, pilih yang lain aja. Berarti dia nggak bakal ngefek deh kayak pakai ini gitu loh. Lebih ke situ sebetulnya untuk tes genetik itu sebagai prediktor begitu.
Baik, Prof. Mungkin satu pertanyaan lagi, Prof, dari Ibu Ayu. Untuk menjelaskan terkait varian gen banyak, apakah berpengaruh varian gen tersebut terhadap penemuan obat baru, Prof? Terima kasih.
Ya, pertanyaannya bagus ya, menarik ya. Jadi apakah dengan ngertinya gen ini ada obat-obat baru yang dikhususkan untuk satu genetik tertentu? Sejauh ini sih pengetahuan saya enggak ya. Tapi tadi jadi labelingnya. Jadi tadi ketika kita mengetahui bahwa seorang itu dia memiliki variasi genetik pada certain gen, maka berarti obat ini nggak cocok untuk itu. Tapi obatnya sendiri nggak sampai secara khusus hanya untuk gen tertentu misalnya, itu enggak. Jadi nanti obatnya tetap hanya saja nanti penggunaannya harus disesuaikan dengan profil genetiknya seperti itu. Tapi jenis-jenis obatnya semuanya sama ya. Cuma nanti cocok atau enggak dipakai untuk kondisi genetik tertentu begitu. Setahu saya begitu.
Baik, Prof. Terima kasih. Mungkin sudah selesai sesi pertama ini. Thank you, Prof, for the answers and the explanation. Maybe it's time to the next conclusion from this theme. Precision medicine that are defined as treatments that are tailored to groups to patient based on specific biomarkers or to individuals based on their genetic profile or status. Pharmacies provide value to clinical decisions for precision medicine by understanding and managing the patient's total drug profile. And the pharmacist needs to be aware of the mechanism of action of these drugs and needs to encourage patients to be adherent with the therapy. One more time, thank you, Prof. Sulis, for being willing to attend this seminar today and give us the new knowledge about the role of clinical pharmacy in precision medicine. Thank you, and thank you, Prof. Okay, maybe ladies and gentlemen, second theme of our seminar is about high performance liquid chromatography in pharmaceutical analysis. Our speaker for this theme is Apotheker Melania Perwitasari, Master of Science from Stikes Mitra Keluarga. Let me read her curriculum vitae. Apotheker Melania Perwitasari, Master of Science, was graduate from Bachelor of Science in Pharmacy, Herbal Major at Gajah Mada University in 2009, Pharmacist at Gajah Mada University in 2010, and as Master Degree of Pharmacy Science and Technology at Gajah Mada University in 2012. She worked as production manager in PT Pesona Bintang Utama Yogyakarta from 2011 until 2014, lecturer in Faculty of Pharmacy Sanata Dharma Universitas Yogyakarta from 2014 until 2015. Now she works as coordinator of Pharmacy Bachelor Program Stikes Mitra Keluarga from 2017 until now. She is interested in analytical of pharmacy. Now, allow me to welcome the speaker, Apotheker Melania Perwitasari, Master of Science, to explain the presentation. Time is yours.
Okay, thank you very much, Bu Maya. Can you hear me?
Yes.
Okay. Okay, let me share this presentation. Before that, I want to greeting my teacher, Prof. Zulis Ikawati. Thank you very much for your time, for sharing knowledge in this event.
Thanks too for invitation, Mbak Melania.
Yeah, thank you, Prof. Okay, I will show my presentation. Okay. So in the session, I would like to talk about HPLC, high performance liquid chromatography in pharmaceutical analysis. So the outline, the topic is I want to explain the pharmaceutical analysis, what is pharmaceutical analysis, and then what is HPLC, and then the application HPLC in TDM or therapeutic drug monitoring. So what is pharmaceutical analysis? So pharmaceutical analysis is the process or series of processes that can be used for the identification, determination, separation, purification, and structure elucidation of the given compound used in the formulation of pharmaceutical product. So the key word is the series of processes. So it's not only one process, but more than one. Yeah, so it called series of process. So it's from preparation sample, and then maybe we could separate the sample, maybe purification, yeah, and then we do the analyze it like identification or determination. Yeah. And I mentioned before about given compound. So what is the given compound that we analyze? It could be active pharmaceutical ingredients or AP, and it could be pharmaceutical excipient. So it can be binder or surfactant, lubricant, and etc. And then it could be contaminant that present in the pharmaceutical product. Yeah, so we should make sure that the pharmaceutical product is free from contaminant. Yeah, and then we can analyze drug metabolite. As we know that drug is can metabolize in liver. And then the type of sample, because this is a pharmaceutical analysis, of course, the sample is the pharmaceutical product, like tablet, capsule, syrup, etc. And then we can have a sample in biological sample, like blood, urine, and tissue sample. So another is impurities and maybe contaminant. And we can do analysis the sample in pharmaceutical raw material. From ICH or International Harmonization, International Conference Harmonization, it describes about drug quality is the suitability of either a drug substance or drug product for its intended use. Yeah. It includes such attributes as the identity, strength, and purity. So from the point of view pharmaceutical analysis, identity, strength, and purity are indeed the main element of the safe and effective use of medicine. So when we want to achieve a safe and effective medicine, we have to make sure about the identity, the strength. The strength, it means the concentration, yeah, and then the purity. Yeah, we want the medicine that is pure, no contaminant, like what, like maybe the purity from the medicine or something like that. So can I say that the purpose of the pharmaceutical analysis is identification, assay, and purity check, yeah, because it assures the efficacy and safety of the medication. So how pharmaceutical analysis impact to socioeconomic? Yeah? So when we do the pharmaceutical analysis, and then we have a pharmaceutical product with high quality, this pharmaceutical product can achieve the drug therapy. Yeah, because of the achievement of therapy, the person can be helped. Yeah, it's not only one person, but it could be population. Yeah, when the population is helped, people can have a movement. When there's a movement, so there's a growth in economic. Yeah, so the financial is becoming bigger. Yeah, so it say that a pharmaceutical, it's what the main the important thing, yeah, the important thing to achieve a socio-economic. As we know now, the pandemic of corona, it's very affect to the financial. Yeah, so it feels that health is very important. So where we do pharmaceutical analysis, where and when, yeah. So pharmaceutical analysis, it can be done from the beginning to the end. Yeah, it means that pharmaceutical analysis can happen when we discover the medicine. Yeah, when we discover drug. Yeah. And then we can do pharmaceutical analysis at development process, yeah. And then it happened in deliver. It means that when drug comes into the body, yeah, we do the pharmaceutical analysis, yeah. And then monitoring the drugs, yeah, like therapeutic monitoring drugs, yeah. When the drug consumed by people, we can monitoring how much the concentration drug in the blood, yeah, or bioavailability. And what type of pharmaceutical analysis, yeah. So there's a lot of types in pharmaceutical analysis. There's qualitative analysis, yeah, and then quantitative analysis. And there is classical method. Yeah, this the old one. Yeah, the old one is like gravimetry, titumetry, volumetry. Yeah, and then there's instrumental method like spectroscopy, chromatographic, and electrochemical. And then there is radiochemical method and thermal method. So I highlight the word of chromatographic, yes, because high performance liquid chromatography is in the chromatographic, yeah. So this method, the HPLC, yeah, is when we see in the table, yeah, we can see that HPLC have 44%, yeah, that analytical method prescribed in USP, the biggest one. Yeah, so it means that HPLC is the most analytical method that prescribing in USP, and because of the precision and the accuracy of the method. So I will explain briefly about HPLC. Yeah, HPLC is a technical in analytical chemistry used to separate the component in a mixture and to identify and quantify its components. So when we use HPLC, we also separate. So we not have to, yes, we have to prepare the sample first. But when we use HPLC, there is a separation too in column. Yeah, so it helps us to separate the component in the matrix. Yeah. So after the separation, we can identify and quantify. So this is the schematic of HPLC system. Yeah. This is a solvent. Yeah. We always use not only one kind of solvent. Yeah. We always use more than one. Minimum is 2 kind of solvent. Yeah. So it's mixture solvent, obviously, and the solvent is a go-to gradient valve. Yeah. So the gradient valve is to set the composition of the solvent. Yeah, composition of the solvent to have a better separation between its component. Yeah. After set the composition of the solvent, and then go to the high pressure pump. Yeah. Because this is a high performance liquid chromatography, we use high pressure pump, yeah, to pump the solvent into the sample injection loop. Yeah. And this injection loop is the place that sample come in. Yeah. The sample come in and mix with the solvent. Yeah. After mix with the solvent, it's going to analytical column. Yeah. This is the heart of HPLC. This is separation happen, yeah, in analytical column. Yeah. After the separation, the component is detect in detector. After that, the data is transferred to the computer and turned into the chromatogram. So this is the cut of the picture of the column. Yeah. So we can imagine like a pipe, and inside the pipe, inside the pipe is a lot of pin. Yeah, a lot of pin. The pin is stationary phase. Yeah, and then into the pipe we come in the solvent. Yeah, it's called liquid mobile phase. Yeah. So the separation occurs when the sample interact with the mobile and the stationary phase. Yeah. So the analyte or the active pharmaceutical ingredient can separate from the matrix, yeah, when have interaction, yeah, between the mobile phase and the stationary phase. The various parts of the sample are separated out based on their polarity. So the interaction based on polarity. They will have varying level of affinity for the mobile phase, resulting in migration through the column at different speed. Yeah, because of the different polarity, the analyte have and the matrix have different affinity. Yeah, with the mobile phase and the stationary phase. Because of that difference of polarity, so they migration or come out from the column with different time. That's why we can separate the analyte and the matrix. So HPLC is generally used in pharmaceutical industry. So HPLC is one of the most method used in pharmaceutical industry. Yeah. So the HPLC is used to analyze finished drug product and to analyze ingredients quantitatively and qualitatively, yeah, during the manufacturing process. So this is achieved through the separation, quantification, and identification of component in a mixture, and can be used to reveal the identity of the drug and monitor the progress of therapy on disease. So this picture is Mikhail Semyonovich Sweat. He is the inventor of liquid absorption chromatography. Yeah. So because of him, we have a HPLC now. That the HPLC is, we can say that HPLC is simple, specific, rapid, precise, and accurate. So that's the reason why HPLC is the most analytical method that used in pharmaceutical industry. So how HPLC in clinical pharmacy? Yeah, that I mentioned before that pharmaceutical analysis can be done in one of them is in monitoring the drug. Yeah. So I will explain just a little about TDM or therapeutic drug monitoring. That the indication of TDM should be limited for drugs with the following characters, like narrow margin of safety, wide inter-individual variation of effect, the clinical effect of the drug that are difficult to monitor, and the plasma concentration of the drug is well correlated with both the therapeutic and toxic effect, and has a well-defined therapeutic concentration range. So when we do the TDM, we do the TDM for avoid the drug toxicity, and then monitor patient compliance, and tailoring drug dose to the individual need of the patient, and monitoring detected drug interaction. The equipment that commonly used in the TDM, one of them is HPLC, but it's not also HPLC like Prof. John Williams said yesterday, that it's not only HPLC, there's immunoassay that we can use too. Yeah? It's such a radioimmunoassay, fluorescence polarization, enzyme-mediated immunoassay, and enzyme-like immunosorbent assay. The difficultness in bioanalytical analysis drug or metabolites in biological fluid, like in plasma, serum, or urine, it's quite difficult, because of the stability characteristic the sample. So the concentration of the analyte is usually very low. So that's why we commonly use HPLC to assay the concentration of the drug or the drug metabolite. So this is one of the example of application HPLC in TDM. So it's said that HPLC are better compared to other assay, like another assay method in anti-epileptic drug. And this is another application, HPLC coupled with MS. So the detector that we usually we usually use UV visible detector, but the detector can be replaced with another detector. One of that is MS. So when we replace the detector, we can detect another compound that cannot detect with UV visible. the sample is contain topiramate. Yeah, topiramate. So this is compare between HPLC, capillary electrophoresis, and gas chromatography. So topiramate is anticonvulsant drug. Yeah, that's indicated for the treatment of partial and generalized seizure. Yeah, so topiramate can be analyzed with HPLC with the UV absorbing moiety, and it's not much with UV because when we see the structure, there's no chromophore and oxochrome at topiramate, so it's difficult to detect with the UV. So we can combine the HPLC with another technique like derivatization, or maybe with another detection like refractive index or conductivity detection, yeah, and another detection. So besides of topiramate, we have a HPLC in lenvatinib. Yeah. So lenvatinib is a drug for thyroid cancer. We can see the HPLC system for the lenvatinib is with Agilent, yeah, Agilent 1220 infinity LC system, yeah, with the pump isocratic, yeah. So with the composition of the solvent from the beginning to the end is the same composition, yeah. And we use the detector with UV, yeah, 244 nanometer, and the column we use the octadecyl silica, and the temperature is with ambient. And the mobile phase, we use sodium phosphate with pH 6.7 and mixed with acetonitrile. Okay. And we the flow rate is 1.0 milliliter per minute. Okay, we can see the chromatogram. Yeah, this is in picture A is a blank serum sample. Yeah, and in the picture B, yeah, we have the lenvatinib. Yeah, lenvatinib in number 1. And then we have the internal standard in number 2, that is erlotinib. Yeah. This is a serum sample that we spike, that we get the lenvatinib standard into the serum. Yeah. But in the picture of C, we can see the chromatogram from the serum patient. Yeah. Patient serum that administration with lenvatinib, amlodipine, and azilsartan. Yeah. So we can see the lenvatinib at number 1. Yeah. We not see the amlodipine, azilsartan, bisoprolol. Yeah. It means that the HPLC can separate lenvatinib with another compound. Yeah, and with another matrix in the serum. Yeah. With this method, we have a linearity, yeah, 0.9998, yeah, with concentration range about 6.25 to 400, and the recovery is 97%, and the CV is between 0.6 to 4.7, and the inter-day CV is 0.7 to 6%. Now, another drug is antituberculosis drug. Yeah. So this is the research use HPLC system with Agilent technology. Yeah, with detector ultraviolet TAD. Yeah, with 245 nanometer wavelength, yeah, for INH, PZA, NA, yeah, and 236 for another compound. So the column used is reverse phase C18, yeah, and then the mobile phase is a composition between water and methanol. So this is the chromatogram. We can see in picture A is blank plasma sample, and the picture B, yeah, there is a plasma sample from the patient, yeah, that consume isoniazid or INH, and then ethambutol, and then PZA is pyrazinamide, and RIF is rifampicin, and NA is for nicotinamide. So the method is meet the requirement of the linearity, accuracy, and precision. So there's quote that nobody is perfect. So do the HPLC. Yeah? So the HPLC, it's not always perfect. There is disadvantages of HPLC. Yeah. Despite that HPLC meets many criteria vital for analysis, but HPLC is time consuming. Yeah. In some way, HPLC is rapid, fast when we compare to another method, but sometimes HPLC is also time consuming too. Yeah. And HPLC is use a relative high amount of organic solvent, yeah, that we see at schematic of HPLC before that the solvent after bring the analyte to the column and then going to the disposal, yeah, so it cannot use anymore this organic solvent, yeah, so it only throw away, yeah, so we have to use a high amount of organic solvent. So we have alternative from HPLC. It's called UHPLC or ultra high performance liquid chromatography. Yeah, so it's better than HPLC. The UHPLC is introducing an environment friendly, yeah, because it's more effective, yeah, and the UHPLC is reducing the consumption of solvent and greater chromatographic resolution, higher sensitivity, and faster analysis. So this is the difference between HPLC and UHPLC. Yeah. We can see from the column. Yeah. We can see the diameter of particle. Yeah. In HPLC, this is 4 micrometer. Yeah, 4 micrometer. And for the UHPLC, this use 0.6. Yeah. Sorry. 1.7. Yeah, so it's smaller than HPLC. Yeah, because it's more smaller, so the separation is better. And for the flow rate, we can see that HPLC use 3.0 milliliter per minute, and UHPLC is slower, 0.6, yeah, 0.6. So because of the flow rate is lower, it means that the consumption of solvent is less than HPLC. And then we can see that the total runtime in HPLC is 10 minutes, and in UHPLC is 1.5. Yeah, it's better time in UHPLC. Yeah, faster than HPLC. About the total solvent consumption. Yeah, It used in HPLC. You can see that HPLC use 21 milliliter, and in UHPLC only 0.66 milliliter for water. Yeah. And for the acetonitrile in UHPLC, we can see 0.53, and for the HPLC is 10.5. Yeah. So the solvent consumption in UHPLC is lower than HPLC. We can see the plate count is bigger in UHPLC. It means that the separation is better in UHPLC. We can see the chromatogram. We can see the band of chromatogram. Yeah, this is more wide, yeah, more wider than the chromatogram in UHPLC. Yeah, it's very tiny in UHPLC. It means that the separation is better than HPLC. So I can make a conclusion that HPLC is the main tool for the most active pharmaceutical ingredients analysis. And HPLC undoubtedly the most important method in contemporary pharmaceutical analysis, not only among the chromatographic technique, but also in general. Yeah, that's why HPLC is the most method analysis used in pharmaceutical industry, and HPLC also used in therapeutic drug monitoring. But HPLC have disadvantages like expensive, high solvent consumption. Okay, I think that's from me. Back to moderator, Bu Maya, please.
Okay, thank you, Apotheker Melania, for giving us a very interesting presentation. Ladies and gentlemen, now comes to the question and answer session. You can write down your name and your institution below in that column, followed by your question. Maybe we have 3 questions first from participants, and maybe Apotheker Melania can answer it in Indonesian or English. It's up to you. And the first question from Febriana Lulu, mohon izin bertanya dalam bahasa Indonesia. Pertanyaan saya, apakah terdapat zat yang tidak dapat dianalisis menggunakan HPLC? Jika ada, mengapa demikian? Terima kasih.
Oke, baik. Saya izin menggunakan bahasa Indonesia. Oke. Pertanyaan dari Lulu ya, apakah ada senyawa yang tidak dapat dianalisis menggunakan HPLC? Jawabannya ada. Ya, jika ada, mengapa demikian ya? Meskipun HPLC ini termasuk salah satu metode yang hampir bisa menganalisis semua jenis senyawa, ya, tapi pasti ada senyawa yang tidak bisa. Contohnya adalah misalkan senyawa-senyawa yang dia contohnya seperti volatil, misalkan ya, atau yang mudah menguap, itu lebih tepat kalau kita menggunakan GC atau gas kromatometer. Mungkin bisa pakai HPLC, tapi performanya atau hasilnya tidak lebih baik dibandingkan dengan GC. Ya. Ketika kita memilih suatu metode analisis, kita kan tidak hanya mempertimbangkan bisa atau tidaknya, tapi juga lebih kepada efektivitasnya. Dalam arti apakah waktunya itu cepat atau tidak, dari segi mudah penggunaannya atau mudah preparasi sampelnya, atau mungkin mudah melaksanakan metodenya, kemudian dari segi biayanya juga, gitu ya. Nah, jadi misalkan untuk senyawa-senyawa yang mudah menguap mungkin lebih tepat menggunakan GC, atau mungkin juga analisis logam, gitu ya. Itu mungkin akan lebih tepat menggunakan AAS, gitu ya. Jadi memang tidak semua senyawa itu dianalisis pasti semuanya bisa dengan HPLC, tidak juga ya, tapi sebagian besar itu untuk senyawa-senyawa di obat-obatan ya, senyawa obat-obatan itu sebagian besar itu bisa menggunakan HPLC begitu. Semoga menjawab.
Baik, terima kasih untuk penjelasannya, Bu Melani. Kemudian pertanyaan kedua dari Ibu Dede, what parameters should be considered in HPLC to analyze drug samples? And second question, selection of the type of column in HPLC that will be used to analyze the sample based on what? Okay, please, you can answer it.
Okay, thank you for the question. What parameters should be considered in HPLC to analyze drug sample? Ya, parameter. So, parameter yang bisa kita gunakan ya, yang bisa kita pertimbangkan itu adalah pertama adalah HPLC itu kan intinya memisahkan, ya, memisahkan analit dari matriksnya. Sehingga berarti kita harus melihat seberapa baik pemisahan itu dari parameter resolusinya. Ya, kita bisa lihat dari nilai resolusinya. Kemudian parameter yang lainnya adalah kita bisa lihat dari apakah pita kromatogramnya itu dia simetris atau tidak. Ya, jadi bisa kita lihat dari asimetrik vektornya. Ya. Kemudian bisa kita kalau dari segi kevalitan dari metodenya, ya kita sebelumnya harus melakukan uji, ya seperti akurasi, presisi, gitu ya. Apakah metode itu memberikan hasil yang akurat dan presisi, gitu. Kemudian untuk pertanyaan berikutnya, selection of the type of the column HPLC that we will use to analyze sample. Oke. Kolom ya, kolom di HPLC itu banyak macamnya ya. Ada biasanya kita bagi menjadi normal phase ya dan reverse phase. Di mana kalau normal phase itu berarti fase diamnya itu adalah polar ya, kalau reverse phase itu fase diamnya adalah non polar. Kapan kita menggunakan polar dan kapan kita menggunakan non polar itu tergantung dari kepolaran dari analit kita. Tadi sudah dijelaskan bahwa interaksi antar analit di pemisahan pada HPLC itu didasarkan pada polaritas. Sehingga kita harus studi literatur dulu terkait analit yang mau kita pisahkan. Ya, polaritasnya bagaimana? Apakah dia polar atau non polar? Kalau kita mau mendapatkan senyawa kita cepat, ya berarti polaritasnya harus dibuat berbeda, bukan dibuat. Polaritasnya itu berbeda dengan fase diamnya. Artinya kita memilih fase diam dengan polaritas yang berbeda dengan analitnya, sehingga kita bisa mendapatkan analit keluar lebih cepat, gitu ya. Gitu. Jadi balik lagi kepada sifat analitnya, polaritas dari analit. Begitu, semoga menjawab.
Baik, terima kasih Bu Melani untuk penjelasannya. Kemudian pertanyaan selanjutnya dari Sinta, Mrs. Melania, regarding therapeutic drug monitoring. In the use of HPLC, is there any special treatment for samples such as plasma before analysis? And how about the detector to plasma analysis? And what are the obstacles in HPLC analysis for this? Thank you.
Oke, thank you for the question, Sinta. Jadi ini termasuk bioanalytical ya, bioanalytical. Jadi sampelnya ini dalam matriks biologi, bisa plasma, serum, darah. Ya. Nah, itu tantangannya adalah bahwa analit itu jumlahnya sedikit di dalam sampel. Itu pertama, sehingga preparasinya itu kita harus hati-hati. Ya, harus hati-hati karena tumpah sedikit udah habis analitnya. Bisa jadi seperti itu ya. Jadi perlakuannya ini harus sangat teliti ya, harus hati-hati. Itu yang pertama. Kedua adalah dari segi stabilitasnya. Karena ini adalah matriks biologi, maka kita harus memperhitungkan stabilitas. Artinya lama proses analisis ini harus kita perhitungkan juga. Ya. Itu. Kemudian yang kedua adalah sampel biologi itu adalah sampel yang kompleks, dalam arti isi di dalam matriksnya itu banyak komponen, gitu ya, sehingga itu bisa mengganggu atau mempersulit ketika kita membaca atau memperoleh analit di HPLC. Artinya kan harus dipisahkan dulu, gitu ya. Nah, lalu prosedur pemisahannya bagaimana, gitu ya? Bisa kita lakukan dengan cara disentrifugasi dulu, ya. Jadi di centrifuge, jadi untuk memisahkan pelet dan cairannya, gitu ya. Kemudian nanti kita ambil cairannya, atau mungkin dengan pemisahan secara fisika kimia, gitu ya. Yang penting adalah kita harus mengetahui analit yang kita tuju itu apa dan bagaimana sifatnya. Sifat mulai dari stabilitasnya, mulai dari kepolarannya, ya, kemudian sehingga kita bisa menentukan metode preparasinya, ya. Kemudian untuk memilih detektor. Detektor itu dipilih bukan berdasarkan jenis sampel kita, tapi detektor itu dipilih berdasarkan analit kita, ya. Jadi bukan karena sampelnya plasma maka detektornya apa gitu, bukan, ya, tapi lebih kepada analit kita. Jadi apakah detektor itu mampu mendetek analit kita, ya. Tuh, kemudian jadi obstacle ya tadi ya yang sudah dijelaskan tadi bahwa hambatannya tadi di sampel biologis itu tadi analitnya konsentrasinya kecil. Ya, jadi kita main konsentrasi kecil tuh harus hati-hati, ya. Maka keterulangannya ini harus bagus, akurasinya ini harus bagus, gitu ya. Terus juga tadi sampel biologis itu kompleks, jadi pemisahannya itu bisa menjadi tantangan sendiri untuk memisahkan antara analit dan matriksnya. Begitu, semoga menjawab.
Baik, mungkin jika ada pertanyaan lagi bisa dituliskan pada kolom chat ya. Mungkin kalau belum ada pertanyaan, satu pertanyaan dari saya, Bu Melani. Untuk pemisahan terkait ekstrak tersebut apakah bisa langsung diujikan dengan HPLC atau mungkin apakah ada treatment khusus terlebih dahulu, Bu Melani? Terima kasih.
Oke, baik. Terima kasih pertanyaannya, Bu Maya. Ini ekstrak berarti konteksnya adalah discover ya, discover obat gitu ya, discover obat atau mungkin develop obat gitu ya. Oke, seperti yang kita tahu, mungkin ekstrak ini apakah konteksnya ekstrak tanaman ya? Kalau memang benar konteksnya adalah ekstrak tanaman, seperti kita tahu bahwa begitu juga halnya di tanaman, bahwa ekstrak tanaman ini mengandung banyak komponen, ya, banyak komponen. Apalagi hanya misalkan sekali ekstraksi saja itu pasti komponennya lebih banyak, ya. Beda halnya setelah diekstraksi kita melakukan fraksinasi, itu artinya kan berarti sudah mulai terpisah lagi, gitu ya. Nah, apakah dari ekstrak ini bisa langsung masuk ke HPLC? Saya rasa kita perlu melihat dulu ya. Pertama itu adalah HPLC itu komponen atau kolomnya itu sangat kecil, ya. Jadi apa yang kita masukkan itu juga tidak boleh terlalu banyak gitu. Nah, karena komponen di ekstrak itu masih banyak, maka perlu kita pisahkan dulu. Ya, masih perlu kita pisahkan dulu. Akan lebih baik jika tadi saya katakan bisa melalui vaksinasi terlebih dahulu, ya, sehingga kita bisa mendapatkan jumlah komponen yang lebih sedikit, gitu ya. Karena kalau misalkan kita paksakan dari ekstrak itu langsung masuk ke HPLC, meskipun sudah di dalam bentuk larutan ya, larutan kemudian sudah disaring masuk gitu, tapi kita akan mendapatkan banyak sekali peak di HPLC dan itu akan sangat sulit, ya, akan sangat sulit melihat analit kitab dan pemisahannya itu sangat sulit dicapai kalau hanya dengan mengatur komposisi fase gerak atau mungkin temperatur gitu ya, atau mungkin juga flow rate-nya gitu. Jadi memang lebih baik untuk preparasi sampelnya itu metodenya lebih diperbaiki lagi, artinya dipisahkan lagi dengan metode lainnya supaya nanti ketika masuk ke HPLC itu tidak banyak peak yang mengganggu. Mungkin begitu, Bu Maya.
Baik, terima kasih Bu Melani. Mungkin karena pertanyaan tidak ada lagi, maka sesi ini bisa kita tutup. Thank you, Apoteker Melania, for the answer and the explanation today. I'd like to thank to Apoteker Melania for the very interesting presentation for today. The conclusion is the purpose HPLC analysis of any drugs is to confirm the identity of a drug and provide quantitative results, and also to monitor the progress of the therapy of a disease. The advantages of using HPLC for analysis are that it requires a small sample size. Testing can be modified depending on level of quantification needed, and it produces reliable results. Thank to all the speakers for the sharing today, and also thank for all the audience for the questions and for the discussion for this morning. Finally, give applause for the speakers and for all of us. Thank you. Okay, now we will start to next session. The oral presentation will be break into 4 sessions. For oral presentation today, let me inform how the oral presentation will be going on. First, the speaker present the material from the video presentation for 10 minutes, followed by question and answer session for 5 minutes for each speaker. After that, the audience can write your name and your institution name at chat column, followed by your question. And the speaker can answer it directly after the question is read by the moderator. Okay, maybe before we start, do you have any question? Okay, no question. If there is no question, we can start the oral presentation today. Now, we will start the first session. I will call the presenters one by one before we start. Miss Anikmawati, are you there? Miss Anik? Okay, maybe still in another room. And Miss Camilla? Camilla Hayatunufus, are you there? Hello? Miss Camilla? Are you there, Miss Camilla? Hello, Miss Camilla? Okay. Miss Yuli Utami? Okay. Miss Yuli Utami is not in this room. Maybe we can start to second session first. Okay. First, Miss Helena Hedida Pinem. We can watch the video first because there are no question and answer session for Miss Lina Hedida Pinem. So we can watch for the next video after Miss Lina Hedida Pinem. The voice can hear.
Good afternoon, everybody. My name is Lina Herida Pinam from Stikes Mitra Keluarga. Good afternoon, everybody. My name is Lina Herida Pinam from Stikes Mitra Keluarga. Thank you for the opportunity so that I can present my abstract from a literature review, which titled the effect of social support on perinatal depression. I will share my PowerPoint. Background of this study is pandemic COVID-19 is a hard time for pregnant women up to postnatal. Maternal feels stressed by the condition of the active spread of the COVID-19 that can infect pregnant women because they are a vulnerable group. In addition to stress with the spread of the virus, the pandemic condition also causes an economic crisis, lack of contact with family and friends who are social support for pregnant women. This can lead to perinatal depression. The result of the fourth study reported that perinatal depression increased during the pandemic. Before the pandemic, 29% of women experienced symptoms of severe anxiety and 15% had symptoms of depression. However, during the pandemic, this increased to 72% feeling anxious and 41% experiencing depression. Even though the condition is not in a pandemic, pregnant women often feel isolated and easily of need, especially in condition of social restrictions due to the pandemic. Social support is a critical thing that needs to be realized by the community. Due to the lack of social support during the perinatal period, it will increase stress on the mother. It can even develop into depression, which will have an unfavorable impact on fetus bonding attachment and development of the baby after birth. Based on this, I conducted a literature review with the aim to identify the effect of social support therapy on perinatal depression. This research aims to determine the effect of social support on perinatal depression with methods literature review. The article says using the electronic database like PubMed, Google Scholar, and Progress, and the number of articles is 18 articles published from 2016 until 2020. 2021. The result of this study is there were 42.9% respondents who got moderate husband support and did not experience postpartum depression, whereas 36.7% respondents with low husband support indicated experiencing postpartum depression. Spearman rank statistical test result p-value is 0.007. It means there was a significant relationship between husband support and postpartum depression. Relation coefficient was R is minus 0.600. It means there was a strong correlation. Some intervention used to reduce depression, perinatal depression is CBT-based internet intervention with peer support to an individual internet intervention designed to prevent postpartum depression. Assessment took place at baseline 4 weeks, 8 weeks, end of treatment, and then 4 weeks and 6 weeks postpartum. A total of 25 women were randomized. Of this, 24 women completed the RCT. Patient held questionnaire 9 scores at 6 weeks postpartum remained below the clinic threshold for referral for treatment in both groups, with depression measure showing a decrease in symptoms from baseline to postpartum. At 6 weeks postpartum, only 4% or 1 from 24 met the criteria for postpartum depression. There was no difference between groups in adherence to the intervention, with an average of 14.55. Second intervention, which have significance to reduce perinatal depression, is peer support through phone calls or text messages. There was a statistically significant difference in Edinburgh postnatal depression scale score with the minus 2.11, NCI 95%, minus 40 to minus 0.3 with p-value 0.03 between the intervention and control groups at 3 months postpartum after adjusting for coverage. The intervention group had a significant change over time compared with the control group. And the third intervention is video delivered family therapy for home visits. Therapeutic alliance was strong, but they demonstrate a statistically significant reduction in the depressive symptoms with p-value 0.001. When compared with mother in the historical comparison group, those GMAR mental health, Clarkson, Keller et al. In the family therapy intervention showed a significant reduction in depressive symptoms with p-value 0.001. Families demonstrate statistically significant improvements in family functioning with p-value 0.02 and cognitive reappraisal with p-value 0.004. And fourth intervention is, I'm sorry, this wrong title. Fourth intervention is WhatsApp Mama. There was a moderate significant main effect of WhatsApp Mama on the maternal distress scores with p-value 0.001 0.001 with the precision is 0.5. The conclusion of the study is lack of social support contributed to perinatal depression. The social support intervention from family, friends, health workers, and especially husbands can significantly reduce symptoms of depression. And social support intervention can take the form of video family therapy for home visit, WhatsApp Mama, web-based approach, assistance in carrying out maternal and infant care activities, and overcoming postnatal pain. Recommendation from this study is the health workers need to innovate digital or direct intervention to provide social support to prevent perinatal depression, especially during this pandemic. Okay.
Thank you for this video. There is no question and answer session, so we can watch the next video. Is Miss Camilla present? Hello, Miss Camilla, are you ready?
I'm ready.
Okay, thank you. Maybe we can watch your video first. After that, we have any question, you can write down in chat column.
Hi everyone. I would like to say thank you for coming to my presentation. It's great to see you all, and which I respect the jury and all of my friends. My name is Camila Donopus, Nutri Nursing Study Program, Sika Susada Hospital. So let's get started. Here, I will present the active findings of oral sucrose on finding during invasive procedures in premature infants. Scoping review. Name of orders, Camilla Hetonopus, Adinda Salsabilah, Nurul Aini, Zakia Arif, Study in Department of Nursing, Stika Susada Hospital. And our grades named Chasman, Lecturer Pediatric Nursing, Department, Stika Susada Hospital. Next is outline. Here, I divide it into several parts. The first is background, aim, method, result and discussion, and the last conclusion. Before entering the background, I will explain the prevalence of babies in the world and in Indonesia. In 2018, there were 28% of babies born with a birth weight record. The prevalence of LBY fell by 1% in 2015, from 40.6% in 2014 to 14.6% in 2015. Premature births are high in 184 countries, ranging from 5 to 80%. With statement, premature babies are LBY in 2/3 of the cases. The next is Indonesia. Indonesia had a baby birth rate of 4,792,117 in 2019. In 2019, 56.6% of babies were born and 6.2% of them were born with low birth weight or LBY. This is a background. We all know that premature babies are babies born with low birth weight babies or babies born less than 26 weeks gestation. For newborn, before and after heel punctures and give non-nutritive sucking with sucrose solution. First, or breastfeeding for newborn for a few minutes before taking action. The next is I'm. The purpose of this study is to determine the efficacy of oral sucrose administration in reducing pain during invasive procedure needling in premature infants. This is an example of a premature baby picture. Next is method. Article selection process. Searching record database is EBSCO, ScienceDirect, Wiley, ProQuest, PubMed. Inclusion criteria. English language articles. Articles containing information about the oral administration of sucrose to infant to relieve pain. Of the articles published between 2017 to 2021 are chosen for limitation. Inclusion criteria. Articles that did not cover invasive needle stick procedures were not considered a urinary catheter insertion (NGT). Keyword: oral sucrose, sucrose, fine, newborn, infant, neonatal, and neonate. Limitation: English less 5 years. Next is result and discussion. Other countries: Christopherson et al. 2018, Norwegia and Africa Selatan. Of the 11 articles chosen, see table 1. At the time, the sucrose could reduce pain in the invasive process in infants, while 3 stated that sucrose was ineffective in reducing pain in infants, either while the invasive process was ongoing or after it was completed. Cook et al. 2017, Go et al. 2018, Goin et al. 2018. The concentration of sucrose used to reduce fine in invasive procedures in 20%. Go et al. 2018. Other articles stated that the equal concentration was between 24 and 25%. For the administration procedure, the baby will be given sucrose 2 minutes before the invasive procedure. And fine measurement will be taken right when the needle is inserted or 30 seconds after the invasive procedure is completed. Sucrose dosage ranges from 0.5 milliliter to 5 milliliter. Next is duration of oral sucrose. The baby will be given sucrose 2 minutes before the invasive procedure, and fine measurements will be taken right when the needle is inserted or 30 seconds after the invasive procedure is completed. Sucrose dosage range from 0.5 milliliter to 5 milliliter. For newborn, before and after heel punctures, and give non-nutritive sucking with sucrose solution. First, or breastfeeding for newborns for a few minutes before taking action. And the last conclusion: oral sucrose ineffective in reducing fine in premature infants when administration 2 minutes before invasive procedure, infusion, and blood collection. Sucrose does 0.5 to 5 milliliter, and concentration 20 to 25%. Those are of reference. And I would like to thank you for taking time to listen to my presentation, and thank you.
Okay, thanks for the presentation, Miss Camilla. Are you ready? Maybe to answer the question?
Yes, sir.
Okay. You can write down your question in chat column with your name and I'll read it to the speaker. Maybe just one or two questions first. No question? For the participants, please. Okay, if there is no question, maybe from Apotheker Melania. How the effect of sucrose on the baby? You can answer it directly, Miss Camilla. How the effect of sucrose to the baby?
Yes. A moment, sir.
Maybe you can answer it, Miss Camilla. Because the time just 5 minutes.
Yes, sir. I can answer.
Okay, please.
How the effect of sucrose to the baby. Um, there are several non-pharmacologic methods for reducing pain in infants, such as skin-to-skin or kangaroo mother care, music therapy, touch therapy, or massage. Furthermore, sucrose administration can be one of the non-pharmacological measures as to reduce pain in infants during invasive procedure. Based on the aforementioned phenomena, the purpose is to determine the efficacy of oral sucrose administration in reducing pain during invasive procedure in premature infants.
Okay, and that's all, Miss Camilla. for the answer? Okay, thank you for the answer. Maybe we can watch the next video. Miss Siti, are you there? Miss Siti? Okay. Miss Siti is not in our room. Maybe we can see from Ajeng. Are you there, Ajeng? Is Ajeng? Are you ready? If your video watch in first session, because Miss Siti and Miss Julie, also Miss Anik are in our room now. Are you ready, Miss Ajeng? Hello? Hello, Miss Ajeng?
Iya, Ibu.
Yes. Are you ready?
Yes.
Are you ready if your video shown right now?
Iya, Ibu.
Okay.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Allow me to thank you for the time given to me and let me introduce myself. My name is Ajeng Ayu Febriani. I'm a student Stikas Mitra Keluarga majoring Informasi. On this occasion, I will present you my journal. In the title is Formulation and Evaluation of the Pill of Gelmas, Extract of Black Glutinous Rice or Alternative for Glutinosa, and Green Tea or Camellia sinensis. First, I will explain the background of my research. Natural ingredients, primarily in the use of natural ingredients that are safer for the skin, has been developed as a sort of antioxidant in cosmetic products. Antioxidants are compounds that
Maybe we can watch again this video because the voice can hear to us. Yeah, I'm sorry for the trouble. Sinta, can you rewatch from 0 minutes again? Hello, Sinta? Okay, I'm sorry for the trouble. Can we watch this video again? Yeah.
Assalamualaikum warahmatullahi wabarakatuh.
Okay.
Good morning, ladies and gentlemen. Allow me to thank you for the time given to me, and let me introduce to myself. My name is Ajeng Ayu Febriani. I'm a student Stikes Mitra Keluarga majoring in Pharmacy. On this occasion, I will present you my journal, and the title is Formulation and Evaluation of the Pill of Gel Mask, Extract of Black Glutinous rice or alternative for glutinous, and green tea or camellia sinensis. First, I will explain the background of my research. Natural ingredients. Currently, the use of natural ingredients that are safer for the skin has been developed as a sort of antioxidant in cosmetic products. Antioxidants are compounds that are useful for neutralizing the increase in free radicals, protecting cells from toxic effects, and contribute to the prevention of disease. Antioxidants are found in many plants. One of them is black glutinous rice or Oriza sativa glutinosa, because black glutinous rice contains anthocyanin. Another natural active ingredient that contains antioxidant is green tea. Green tea is a plant that contains catechin as antioxidant. And then formulation of the problem. The formulation of the problem in this research is how is the physical stability of the pill of gel mask extract of black glutinous rice or Oriza sativa glutinosa and green tea or camellia sinensis with various HPMC concentration of 2.5%, 3%, and 3.5%. Store air 4 derajat Celsius, 25 derajat Celsius, and 40 derajat Celsius for 28 days. Research purpose. The purpose of this study was to develop a pill of gel mask preparation formula from black glutinous rice extract and green tea and evaluate the preparation of a pill of gel mask preparation of black glutinous rice extract and green tea. My literature review, black glutinous rice is rich in anthocyanin. Anthocyanin are natural pigments belong to the large family of water-soluble flavonoids, which are responsible for giving plant the red, purple, and blue color. And green tea is a plant that contains antioxidant. The main content is catechin or polyphenol. Catechin are the main group of green tea substance. Peel of gel mask is a skincare cosmetic preparation in the form of a gel and is applied to the skin within 15 until 30 minutes until it dries. This preparation will form an elastic transparent film layer and making it easy to peel off. My research methods. My research design is experimental. Research. My research was conducted in place is pharmacy laboratory of the University of Indonesia Depok and at the technological laboratory of Stikes Mitra Keluarga. And research time. My research was carried out from March to May 2021. My population and sample in my research is black glutinous rice and green tea. Research hypothesis: extract of black glutinous rice and green tea can be made into pill of gel mask preparation with HPMC concentration of 2.5%, 3%, and 3.5%, and can meet the requirement of the physical evaluation test. This is my pill of gel mask preparation formula. And then my HPMC concentration is 2.5%, 3%, and 3.5%. The function is a gelling agent. How to make a pill of gel mask? The material where weak HPMC was developed by adding aqueous at a temperature of 70 derajat Celsius until 80 derajat Celsius and stirred until it was clear and homogeneous. Mixture 1. And then polyphenol alcohol is added with distilled water at room temperature, heated on a water bath at 80 derajat Celsius until it expands completely, then cool. Homogenize using a homogenizer, a mixture 2, enter mixture 1 into mixture 2 little by little, homogenize using a homogenizer until a base gel is formed. Mixture 3, polypropylene glycol and methyl paraben were mixed until homogeneous. Mixture 4, mixture 3 is put
into mixture 4 and add black glutinous rice extract and green tea extract, homogenize with a homogenizer. And final evaluation test. Stability evaluation, 1 organoleptic test with test shape, color, and smell, and then pH test by using a pH meter, homogeneity test with 0.5 gram is measured on the slide to see if there are pores vertical, and then viscosity test, the test was carried out with a profile viscometer type LV. Spread forward test, as much as 1 gram is measured on a glass slide and left for 1 minute. And dry time test, 1 gram of mass gel is applied to the forearm skin. Result and discussion. This is my organoleptic test. The conclusion, the organoleptic result at temperature of 4 degrees Celsius, 25 degrees Celsius, and 40 degrees Celsius saw stable in color, shape, and odor until the stored limit and there was no test separation. And then pH test. The conclusion from the table and graph, it can be seen that the pH test result at temperature of 4 degrees Celsius, 25 degrees Celsius, and 40 degrees Celsius still enter the range of 4.6 until 5.5. The pH value of the preparation must match the pH of the vessel skin, which is 4.5 until 6.5. Because if the pH value of the preparation is too acidic, it will cause skin irritation. Whereas if the pH value of the preparation is too alkaline, it can cause scaly skin. And then homogeneity test. The conclusion from the table and figure, it can be seen that the three formula at temperature of 4 degrees Celsius, 25 degrees Celsius, and 40 degrees Celsius saw homogeneous result because they did not show any coarse grain. And then viscosity test. The conclusion from the table and graph, it can be seen that the viscosity, the result at temperature of 4 degrees Celsius, 25 degrees Celsius, and 40 degrees Celsius are still in the standard range, which is between 600 until 2500 CPS or centipoise. And then dry time test. The conclusion from the table and graph, it can be seen that the result of the drying time test at 4 degrees Celsius, 25 degrees Celsius, and 40 degrees Celsius are still in the standard range, which is between 15 until 30 minutes. The increase in drying time during the storage period of 28 days at room temperature, hot temperature, and cool temperature can occur because the longer the storing time, the longer the preparation is affected by the environment, for example, air. The conclusion from the research that has been done, it can be concluded, 1. Black glutinous rice extract and green tea can be formulated as a pill of gel mask. Preparation based on HPMC 2.5%, 3%, and 3.5%. In the stability test that can be carried out, the three formulas still meet the standard from the pill of gel mask preparation. My recommendation further this need to be carried out, namely dispersion test, addition test, and preference test to improve the quality of the pill of gel mask preparation. And the two antioxidant testing is also needed to determine the activity of antioxidant compound in the preparation of pill of gel mask extract of black glutinous rice and green tea. This is my reference, and thank you for attention. Assalamualaikum warahmatullahi wabarakatuh.
Okay, thank you for the presentation, Ms. Ajeng. Maybe one or two questions first. You can write down your question in chat column. Followed. Okay. The first question for Ajeng from Febriana Lulu. Why did you choose black glutinous rice as the active ingredient? Maybe you can directly answer it, Ms. Ajeng. Thank you.
Okay, thank you Lulu, for the question. I want to answer because black glutinous rice contains anthocyanin substance that can soften the skin and delay premature aging. Thank you.
Okay, because it has a compound for anti-aging. And the second question from Herlin, how do you mix the two active ingredients into a pill of mask formula? Thank you. Can you answer it, Miss Ajeng?
Thank you, Herlin, for your question. How do you mix the two active ingredients into a pill of mask? I extract the two active ingredients using the extraction process, namely its maceration. Thank you.
Okay, maybe it's the last question from Dia. What other materials that can be used besides HPMC as a gel base, and why you use this material instead of the other materials?
Okay, I want to answer the question because HPMC is a good gel base for the masker peel off.
Maybe another material?
Another material, you can rosella and then pegagan. Thank you.
Okay, maybe it's the material gel base. HPMC, rosella, the extract or active compound. The question is about the material for gel base.
Okay, yeah. Another material you can PVA because PVA PVA akan membuat si masker peel off itu mudah untuk dikelupas.
Okay. Or polyphenol alcohol.
Yes.
Okay. Thank you for the answer, Miss Ajeng. Now we can watch the next video. Maybe I'll call the next speaker first. Miss Anik, are you ready? Miss Anik?
I'm ready.
Enigmawati. Okay, thank you for attendance. The topic is about the effect of bay leaf in reducing uric acid levels. Now we can watch the video first. Please, Sinta. Okay, thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Nice to meet you all. Let me introduce myself. I'm Anik Enigmawati from ITS PKU Muhammadiyah Surakarta. On this occasion, allow me to present the result of our research on the effect of bioleaf 2 in reducing uric acid level. Start from background. This is a type of arthritis that is occurred due to a build-up of uric acid crystal. This problem can cause discomfort from the patient, so it can interfere with daily activity. Management to reduce or eliminate discomfort due to gouties by consuming a tube of bioleaf. It contains flavonoid compound which have anti-inflammatory properties. This therapy has no side effect and it is not expensive. The purpose of this study was to determine the effect of bioleaf 2 in reducing uric acid level in gout patients. The research time and place. This research was conducted in Mangurejo, Boyolali, Central Java in March 2020. There is methods. We use quasi-experimental design with one group retest post-test design, and the respondent, the number of sample in this study was 20 respondents. For instrument, we use a uric acid check tool. And then for intervention, our research, data collection is done by, first, its respondent is checked for uric acid level. This data is used to find out pretest data. Second, its respondent is given an intervention for 7 days. Every day, the respondent consume the stew of bay leaves 2 times a day for 7 days. How make it take them by leaf or put into 500 milliliter of water until it fills the remaining approximately 300 milliliter. And then on the 8th day, each respondent was checked for uric acid level. For data analyzed with test. And then the result of our research, after collecting data and then analyzing it using a test statistical test, it shows the average value of uric acid level before being given value 2 was 7.070, while the average value of uric acid level after being given by leaf 2 was 4.930. From the result of the mean before and after, obtain the difference in value of 2.14 from 20 respondents. P-value is 0.000 less than 0.05. It can be concluded that there is significant difference in uric acid level in reducing uric acid level before and after being given a stew of bay leaf. For conclusion, there is an effect of giving bay leaf decoction on reducing uric acid level. This picture is document when we did the research. The first give explanation about the code. The second check the uric acid level, and then the third give demonstration how to make bay leaf stew. Okay, that is the presentation of our research that I can convey. Thank you for attention. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Ms. Ani, for the presentation. Now, the session for question and answer session.
Yes.
Maybe 1 or 2 questions you can write down in chat column first.
Yeah. I'm sorry. Yes.
Yeah.
Any answer for me? Any question for me?
We still waiting, Miss Yuli. Okay, just 1 question. Oh, okay. 1 question, Miss. What compound in bay leaf that can reduce uric acid levels? And do the people take other drug while consume the bay leaf to treat their cold? And how much leaves that they consume to reduce this uric acid? Thank you, Miss.
Yes, I'm to try answer your question. How make it by lift of steel, 10 by lifts, boil into 500 milliliter of water until it boils to the remaining is approximately 100 milliliter, and then it can consume the respondent. Apa namanya? Saya ini ya, apa namanya, combine. Jadi pemberian daripada rebusan daun salam ini kita berikan selama 7 hari begitu, dimulai dari pengecekan awal hari pertama, kemudian dievaluasi pada hari ke-8. Responden diberikan rebusan daun salam ini dari hasil rebusan 10 daun salam yang direbus, kemudian diberikan air kurang lebih 500 ml sampai mendidih kira-kira tersisa 200 sampai 300 ml. Kemudian setiap hari responden ini akan minum selama 2 kali begitu.
Okay. Any answer again, Miss? Or that's all? Okay. Thanks for the explanation, Miss. So maybe it's time to take a break. Yeah, we can join again at 1 p.m. And Miss Yuli, you can join at 1 p.m. and we watch your video after break. Okay, thank you for all. And we can leave room now. We meet again after break. Thank you.